Hello students, this video is intended for the purpose of reviewing a little bit before the final exam. And some of the things that are in your exam are systems of linear equations. And of course, you are going to have some word problems there. So what I want to do is just review a little bit of the homework problems that were on the last homework assigned, homework 5. And so, for example, here, problem number 2, a lot of you answered this question by guessing, which was not the correct way. So what you were supposed to do here was to create 3 equations. The first one, it says the sum of 3 numbers is 6. The second equation will come from here. The third number is the sum of the first and the second. And the last equation will come from here. The first number is 1 more than the third number. So my system of equations in this case will be, well, first I'm going to define my variables. And I'm going to say A is equal to the first number. B is equal to the second number. And C is equal to the third number. So by the first statement, I could say that A plus B plus C is equal to 6. By the second statement, we could say that the third number is the sum of the first and the second. And by the last statement, the first number is 1 more than the third number. So the third number is C, and 1 more will be plus 1. However, before you solve the system with a matrix, you have to make sure that all of your variables are on the left side. So in this case, I could take positive A across, positive B across, and do the same thing here with C. So my new system is going to look like this. A plus B plus C is equal to 6. My second equation will be negative A minus B plus C. And now you notice if we take these 2 variables to the left side, we're left with nothing on the right, so we represent that with a 0. And here we will have plus A minus C and then equals 1. Now from here, to construct the augmented matrix, remember that it's a matrix that contains the coefficients and also the constant terms. So to do that, you take the coefficients, 1, 1, 1, constant term is 6. Then we have negative 1, 1, 0. And then we will have 1. We don't have a B on the third equation, so we represent that with a 0. And then negative 1. And the constant term is a 1. Now what you need to do to solve the system, of course, if you're not solving it by hand, will be to type it on your calculator. And before that, you will have to go to Menu, Matrix, and then you will select the option for Reduce Row Echelon Form. After that, you need to enter a matrix that will be of 3 rows and 4 columns. Now, on your exam, you will have to not only solve a system, but also come up with the correct equations. You do have a problem that talks about money, talks about the number of, so you're going to have to be careful when you formulate those equations. And of course, make sure that you define your variables. I'm going to do one more problem from the same homework, and this will be problem number 24. And so here we have at this particular high school, during a football game, they scored 37 points. 6 points are awarded for each touchdown. And then we have extra kicks that are worth 1 point. And of course, we have the 2-point conversion. Now the teams score 1 fewer 2-point conversion, so I'm going to save that statement for later. But before that, let's define our variables. Now, if you read the question, it says how many touchdowns were made during the game. So to define my variables, I'm going to use x, y, and z. And since the question is asking me how many, I will define my variables as the number of touchdowns, y will be the number of extra kicks, and z will be the number of 2-point conversions. Now, my first equation is going to come from the statement given here. They score a total of 6 points. And so I think we all know, but in case you don't know, a touchdown is worth 6 points. An extra kick is worth 1 point, and the and the 2-point conversions, of course, are worth 2 points. So when we consider the total number of points, we're going to have to consider how many points each thing is worth. So we will say 6 points are awarded for each touchdown. We don't know how many, so we'll represent that with the next. 1 point for any extra kick, so 1y, and 2 points for the 2-point conversion. And the total of that will be 37 points. That is equation number 1. Now for the second one, I can use the statement here. The team scored 10 times during the game. So X number of touchdowns, Y number of extra kicks, and Z number of 2-point conversions, that equals a total of 10. They scored 10 times. For the final one, we use the statement that I have highlighted, and it says the team scored 1 fewer 2-point conversions than extra kicks. So in this case, I could use the equation for extra kicks. So extra kicks is represented by y, and it says that they score 1 fewer 2-point conversions. So the 2-point conversions is z minus 1. So remember that before you can solve that with a matrix, you have to move everything to one side. So in this case, we will have positive y minus z is equal to negative 1. And so that will be my second equation here. Y minus z is equal to negative 1. Now, your exam also mentions a different way to solve an equation, a system of equations. And that one is called the inverse method. For the inverse method, you have to consider 3 matrices. The first matrix is called A, which represents the coefficients. So the coefficients are being represented by 6, 1, and 2. Then we have 1, 1, 1, 1, and negative 1. Then we have to consider the matrix with the variables. In this case, our variables are x, y, and z. And if we multiply those, we will obtain the constant terms. So then we create a matrix that we call the constant terms matrix. And in this case, that will be 37, 10, and negative 1. Now, to solve this method, the inverse method says that you will need to the answer to your system, so the variables x, y, and z, will be given by multiplying the inverse of the coefficient matrix. So notice how I have here the negative 1 times the constant matrix, or the constant terms matrix. So what you will have to do is enter 6, 1, 2, 1, 1, 1, 0, I forgot that 0 here, 0, 1, negative 1, and then make sure you do include that inverse, and then we'll multiply that times the constant matrix, 37, 10, and negative 1. So one thing we could do here is enter the coefficient matrix. And in this case, we need a 3 by 3. Our coefficients were 6, 1, 2, 1, 1, and 1. And then 0, 1, and negative 1. We need the inverse of that, so make sure you enter something like this. You will need the negative sign, which is below number 3, and then times the constant matrix, which is a 3 by 2. So what I'm going to do is select a 3 by 3, and I'm going to need 3 rows, but only 1 column. 37, 10, negative 1. Okay, and I see that I did something wrong. So I guess I formulated my equations wrong, so sorry about that. So what I was supposed to do was to have z is equal to y minus 1. So it's not a huge problem. We could change that. So then in this case, our third equation should be the following. Positive z minus y. So I'm going to go back here. This will be negative, and this will be positive. And I know I did something wrong because we cannot have 43 over 9 touchdowns, right? We should get an integer there. So I'm going to go ahead and copy this matrix by highlighting it and then just press enter. And then I'm going to go back here and change that sign to positive and the y to negative. Let's see if that works. Yes, and that is the correct answer. So we will get 5, and remember this is representing x, y, and z. So x is equal to 5, y is equal to 3, and z is equal to 2. So that means they scored 5 touchdowns, 3 extra kicks, and 2 two-point conversions. Okay, now let's talk a little bit more about the reduced row echelon form, but what we're going to do is just do a few of the steps by hand. I hope you remember. And so what I'm going to do is, there is one problem where you have to not only construct the augmented matrix, but you also need to, and I'm going to use example number 2. So we start with 1, negative 4, 3, negative 27. And here we'll have 2, 2, negative 3, and 22. We don't have an x, we don't have a y, but we have 4z, and this is negative 16. So remember, when we do problems like this, we have to work first on the first column, and our goal is to get identity. So you are given a system, you have to create the augmented matrix, that will be your step, but then you have to select which one is the correct sequence of steps. And so what I want you to remember is that first you need to work on getting that 1 on your column, and after that you work on getting those zeros. So in this case, we need to make this 2 turn into a 0. So what I'm going to do is say R1 times the additive inverse of 2, which is negative 2, plus R2. R1 stays the same. And so if we do this, will be negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 4 is positive 8, plus 2 10. Negative 2 times 3 is negative 6. Minus 3 is 3. Negative 2 times negative 27 is positive 54. Plus 22, it will be positive 76. Now, our third row already has that 0 on the first column, so we can move on with that. And now, our next step here is going to be to make that number 10 turn into a 1. So remember, now we need to move on to the second column. And so the way that we're going to make that 1 will be by multiplying R2 times 1 over 10. And so that will give us 0, 1, 3 tenths, and 76 over 10. And so the options on your test, you have 4 options, 4 different sequences, and you have to pick the correct one. And I can tell you that if you know how to construct the augmented matrix, you could reduce your options by 2. So I'm just hoping that you can get that. Just remember that you have to have zeros below the ones. And that is why we call this form, or in this case, it's not reduced row. It will just be reduced echelon form. Remember, this word, it refers to the stair pattern or step pattern that you see there. Now, we did cover a lot of systems of equations, but it was always or usually linear with linear. Now, let's see what will happen when you have a quadratic equation and a linear one that form a system. So, this is a quadratic, and let's say that the linear equation intersects the quadratic like that. So in this case, keep in mind that those intersection points are solutions. So the system actually has 2 solutions. We could also have another one where you have a quadratic and you can have a linear function like that. So you can see that the 2 will never intersect. So in this case, you have no solutions, or we may say none. And there is a third case where you could have a quadratic equation, and then you could have a linear intersecting at one point. And this is like, you will learn a lot of this in calculus. So to summarize this, a system that is formed by a quadratic and linear equation can have 2 solutions, 1 solution, or no solution at all. Now, since we did not study how to do this in class, I'm going to show you a quick way that you could solve this on the calculator. So we're going to go to the graphing section. And we're going to enter, let's say, x squared minus 2. Enter. And then let's go ahead and graph a linear function. So you press tab, and let's graph 4x. We got the 4. Enter. And so you can see here clearly that there is an intersection. So one thing you can do to find what the number is, the x value, will be to go to menu, and then analyze graph, and then intersection. Now, as you can see on this side of your calculator screen, it would say lower bound, and you see a dash line on the y-axis. So what you could do is use your mouse pad, drag that line to the left side of that intersection. Then you press your center button. And then the word, it switches to upper bound. So that means we have to drag another line to the right side of the intersection point, press the center button, and that way you will get a solution. And so here the x value is negative 0.449. Now remember, you could have one intersection or two or none. So this one, it seems to me like it could have one more. Now, I'm not very sure about it, but I can do something. I could zoom out. I'm going to zoom out again. And you can see that there might be another, well, there is another intersection there. If there's something on your way, you could just drag it across so you can move it. So now I'm going to try to get that other point of intersection. So I'm going to go to Menu, Analyze Graph, Intersection. Now for my lower bound, I want it to be on the left side of that point that I have marked in green. Press the center button and then the word switches to upper bound. So that means we need that line to be on the right side. Press the center button. And now we get the x and the y values. So we have 4.45 and negative 0.449. You do have a question like that, so make sure you do try to solve it. Another thing that we could say, that I could tell you, there is one equation that it might look a little intimidating at first, and I'm not going to give you the exact same equation, but it looks like something like this. 3x plus 2 to the power 2 over 3 is equal to 9. And so there is a longer version to solve this equation. And what that means is the power 2/3. It means that you have 3x plus 2 raised to the second power, and then you're taking the cube root of that. And when we have exponents as fractions, the denominator becomes the index of your radical. So in this case, I know it's a cubic root. So if we say that that is equal to 9, how would you undo a cube? And the answer to that question is you raise it to the third power. That will cancel out the cube root. So we end up with 3x plus 2 squared. And 9 to the third power is equal to 729. Now, how do you undo a square? And the answer is you take the square root. So that will take care of that. We have 3x plus 2 is equal to the square root of 729, which is 27. From here, we all know that we need to take this plus 2 across, or subtract 2, because that is the inverse operation. So it will be 27 minus 2. So 27 minus 2 is 25. And here the 3 is multiplying to the x, so we need to divide by 3. So that is a way to solve it. Another way, a little shortcut that we could take, and we did not have enough time to go over all the rules with exponents, but we did go over a lot of inverse operations and multiplicative inverse concepts. So one thing we could do here is we take the 3x plus 2, we take the exponent and we move that across. And so when we do that, the 2/3 is going to change to its multiplicative inverse, or the reciprocal, which is 3/2. And so if we go to the calculator and we enter this quantity here, 9 raised to the 3/2, going to clear my screen. So actions, clear history. And so I'm going to enter 9 to the power of 3 halves. And that gives me 27. So if I do that, I will get the same number that I had before. And that number is 27. Same number that I had here. Then we have 3x plus 2, and I think you all feel pretty comfortable solving an equation like this. It will be 27 minus 2, that's 25. The 3 is multiplying, so we have to divide by 3. That question, it is one of those where you have to fill in the bubbles. You do have to give a numerical answer. So make sure you do try it, and if you want to get a decimal approximation, remember that you will have to enter that on your calculator and, of course, press Control Enter. So 25 divided by 3, Control Enter. And so it will be 8.33. One last thing I would like to show you, or just go over quickly, it is how to graph inequalities on your calculator. And I know that this concept is still pretty fresh in your mind, but it doesn't hurt to practice how to check your work. And so you do have a couple of problems with inequalities where you have to select the correct region where the colors intersect. So the problem is that the equations are in standard form. So remember that you have to convert them to slope-intercept form. So in other words, we have to solve for y. In this case, we take the positive 2x, it becomes negative 2x plus 3. And then we have this 4 multiplying to the y, so we know we have to divide by 4. We're dividing by a positive number, so we do not need to reverse the number. I'm sorry, the inequality symbol. But we have negative 2x divided by 4 plus 3/4. And so you can actually enter on the calculator, you can enter it in this form, or you can enter it in this form, or if you feel confident, you could reduce. So this will be negative 1/2 of x, or negative x over 2 plus 3/4. Now let's change another one. So this will be 5x minus y. It is greater than or equal to 2. And in this case, we're still solving for y. So we start like this, positive 5x, take it across, it becomes negative 5x. And then we have a plus 2. So in this case, y is being multiplied by negative 1. So one thing we could do is to change it to positive y, is multiply by negative 1, or divide by negative 1. So I'm going to choose to do that. I'm going to divide by negative 1. You will get the same answer. But since I'm dividing by a negative number, it's important for you to remember that we have to reverse the inequality symbol. And after here, it will become negative 5x divided by negative 1, 2 divided by negative 1. So you need to be careful with those negatives. Negative 5 divided by negative 1 is positive, so positive 5x. And here, positive 2 divided by negative 1 is negative 2. So what I need to do now is enter these two inequalities on my calculator. So here we're going to go to the graphing section. You could just press this button with the calculator. Oh, I don't know what happened there, so let's just press home and then graph. Let's delete everything we have there. Okay, it's not working, so I'm going to go to Menu, Actions, Delete All. Now, I also want to change my view to standard view, so I'm going to go to Menu, Windows Zoom, and then Zoom Standard. So I'm going to press Tab, and you guys could see there's an equal sign here, right? So what I'm going to do is delete. And once I press the delete button, as you can see in red here on the calculator. I'm going to select the correct inequality symbol, so in this case it's greater than or equal. So I'm going to enter negative x divided by 2 plus, and here if you have a coefficient which is a fraction, I will recommend that you enter that in parentheses, or even if it's just a constant term, just to make sure that the calculator reads that correctly. And you can see here the calculator will shade for you. And now I'm going to enter the second one. So again, press the delete button. And now we need less than, and we will need 5x minus 2. And we press enter. And so remember, the solution to the system of inequalities is the shaded region, where the two colors intersect. I know here we have blue and blue, so you will select the darkest blue, the area shaded in darkest blue. So this will conclude the video. I hope you watch it, and tomorrow you will have your exam during 6th period, which will be from 2:30 until 4.